Dear students, now we are going to see the subject linear integrated circuit. The subject code is EC3451. Under that, the topic is open and closed loop analysis of operational amplifier. So upon completion of this open and closed loop analysis of operational amplifier, the students will be able to write down the advantages of using op-amp in closed loop configuration. In open loop configuration of op-amp, that is the simplest possible way to use an operational amplifier in open loop mode. Since the gain is very large in open loop condition, the output voltage V0 is either at its positive saturation voltage plus V saturation or negative saturation voltage minus V saturation, as the V1 is greater than V2 or V2 is greater than V1 respectively. So the figure shows the operational amplifier in open loop configuration. In open loop configuration, there is no feedback resistor is connected between the input and output. Only the two input signal V1 and V2 are applied to the non-inverting and inverting terminal respectively. The voltage transfer characteristics of open loop operational amplifier is shown in the second figure. For a small range of input signal from a point to A to B, it behaves linearly. The range is very small and practically, due to the high open loop gain, the operational amplifier either shows plus V saturation or minus V saturation level. This indicates the inability of op-amp to work as a linear small amplifier in the open loop mode. Hence, the op-amp is generally not used. We know that the DC supply voltage applied to the operational amplifier are VCC and minus VEE, and the output varies linearly between VCC and minus VEE. Since the gain is very large in open loop condition, the output voltage V is either a positive saturation or a negative saturation. The condition is V1 greater than V2 or V2 greater than Vi respectively. So the figure shown that's a very small noise voltage present at the input also gets amplified due to its high open loop gain, and open loop operational amplifier gets saturated. It can be seen from the figure. Only for small range of input signal it behaves linearly. This range is very small and practically, due to high open loop gain, op-amp either shows plus V saturation or minus V saturation level. This indicates the inability of op-amp to work as a linear small signal amplifier in open loop mode. Hence, the operational amplifier is generally not used in open loop configuration. Such an open loop behavior of op-amp finds some rare applications like voltage comparator, zero crossing detector, etc. Closed loop configuration of operational amplifier. The utility of operational amplifier increases considerably if it is used in closed loop mode. The closed loop configuration of op-amp is possible using the feedback. The feedback allows the feedback. Some part of the output is back to the input. In linear application, the op-amp is always used with negative feedback. The feedback helps to control the gain, which otherwise drives the operational amplifier into saturation. The negative feedback is possible by adding a resistor like this figure called feedback resistor. The feedback is said to be negative as the feedback resistor connects the output to the inverting input terminal. The gain resulting with feedback is called closed loop gain of the operational amplifier. Due to feedback resistance, there is a reduction in gain. The closed loop gain is much less than the open loop gain and is independent of it. Most of the linear circuit use op-amp in closed loop mode with a negative feedback with RF. This is because due to the reduced gain, the output is not driven into saturation and the circuit behaves in a linear manner. So the possible questions on this open and closed loop configuration is: explain in detail about the open and closed loop configuration of operational amplifier. Thank you.